Auto constrain in version 20 is going to provide us an interactive way to detect and apply assembly constraints to imported data regardless of where it came from. In this demonstration we're going to be opening a pneumatic slide from a supplier. And this assembly was brought into Solid Edge through the step translator. And the first thing that we'll notice as we open up this assembly is that all of the parts are grounded, so there's no intelligence between the components. I'm going to use the move part command and select this top plate, and as I move that plate you can see that it moves independently. Again, no relationships built between the different components. And so what auto constrain is going to do is give us the ability to apply assembly constraints between these components interactively. The first step though is to remove the ground relationship on all of the components. So I'm using the option to select set 1 against itself, and we're going to again use this to remove the all the ground relationships. As a matter of fact, Solid Edge is going to tell us that some of the relationships have been deleted and give us the opportunity to undo that if we would wish to. And so to simplify the process, I'm going to hide the movable side of the pneumatic slide and just focus in on the stationary side. And so as we run the command again, we're going to change the options to select set 1 against the parts that are currently shown. So the first component that we're going to select, which is the first part in the select set, is the gold block. The second select set is all the remaining components. And the first thing we want to look for is just axial alignments. So go ahead and process that, and you're going to see how quickly Solid Edge comes back with all the relationships that it has detected. Now if I pick the part name, you can see that it highlights graphically on the screen, and if I pick the relationship, you're able to see graphically that relationship between the components. As you can see, they're all listed under the gold block, and that's because we told Solid Edge to detect all relationships between the gold block and the rest of the components. Once we're happy with those relationships, we can simply click accept, and then using the same select set we can go and search for other types of relationships, in this case mates and planar alignments. Again, you can check each of these relationships by selecting them graphically. And notice that it did not find any relationship between the air port plug and the side of the block. And that's because it's recessed into the block slightly. So how we can detect that is to change the options to allow an offset. And so now if I come down here, you can see that for the air plug, if I select it graphically there, you can see that it found a relationship now, and that is recessed 0.04 millimeters into the block. It's also detected some relationships between the piston rods and a face on my block, which I don't want to create this relationship because I want those rods to move in and out freely. So we're just going to uncheck those relationships so it does not create those. You can see that as I unchecked it, it also unchecked underneath the gold block. And that's because that relationship is between those two components, and each relationship is listed twice. So we'll go ahead and accept those changes. Next thing we're going to do then is show the components that we hit earlier. Again, moving to the movable side of the slide, and we're going to run that same command again. First select set is the top movable block. Second select set is all the other components. Using the same process, I can detect mates and planar or axial alignments in this case. I'll go ahead and process that. One thing I'd like you to notice is that for each guide or movable slide, you can see that it found a mate and two planar alignments. Excuse me, two axial alignments. Even though there are 8 holes in that block, it only found 2 because Solid Edge is intelligent enough to know that it only needs 2 of those axial alignments to fully constrain that particular component. The last thing we need to do is then apply a relationship between the stationary side and the movable side, and I'm going to do that through the piston rods. So run the command one last time. This time we'll change the options to the first select set against a second select set. Second select set being the bolts and the piston rods. And you can see that it found the mate relationships in the bottom of the counterbore holes and also the axial alignment between the piston rods. And so last thing we'll do is show all the components, and going through that same process of using the move command again, we'll select that movable slide, and as I move that now you can see that all the parts stay relative to each other based on the assembly constraints between the components. So you can see that we were able to bring in this assembly from a foreign system and interactively apply the assembly constraints automatically.